Ocean Stewards. The One Ocean crew is here today looking at the MicroSWIFT Buoy data, and we're joined by Jacob Davis from the University of Washington's Applied Physics Lab, who joined us for the deployment of this buoy on June 23rd. And it's currently a month later, it's July 23rd. So we're going to look at this data and what it's collecting.
Thanks for having me. Great to see you all again. Yeah, so I wanted to step through some of the buoy data that you guys collected. So here, first, I'm showing the Backyard Buoys app. This is an application primarily meant for phones, but you can also put up on your computer. And this shows all sorts of wave buoys that are deployed throughout the Pacific Ocean. So here I am in the blue dot. I'm on the west coast of the United States in Seattle, Washington, at the University of Washington, where I just graduated with my PhD.
Congratulations.
Thank you. There's all sorts of buoys along the west coast, but if we move up closer to Alaska, this should be MicroSWIFT 167, which you all deployed south of the Aleutians. These green rings actually show the sort of health or battery life of the buoys, and so you can see that this one that you deployed is actually pretty close to the end of its life. So we click on it, you see this is indeed MicroSWIFT 167. Here we see that we saw received new data about 11 hours ago. So that's probably suggesting it's actually on its last legs because typically these report about every hour. But its last reported wave measurements show that it recorded wave heights of 4 feet and 7-second wave periods. So that's how frequently the waves are coming. And these waves were measured from the northeast. So waves coming from the northeast or going in the direction of this arrow. So we can actually expand this and look at some charts of those metrics. So here is wave height over time. You can see it's been relatively flat, at least up to the past few hours this buoy is recording, as well as wave period, wave direction, and then also water temperature. And what's neat about this application is that you can actually go explore any of these other buoys. So for example, this is another buoy that we've actually moored out in the open ocean called Station Papa. And so if you're interested, you can go and check these out too. See, conditions have been relatively nice and calm in the Pacific, but keep an eye out for some storms.
Yeah.
Yeah. All right. And then so let's see. I made a quick map of the track of the buoy that you all deployed. So this is MicroSWIFT 167. And this
Great.
map, yeah, is showing the larger context of Alaska, right? So right here, this is Alaska and the Aleutians, and this is where the buoy is deployed. And then this square right here is showing this larger map. And so this sort of squiggly line here is actually showing the track of the buoy. It is free drifting. It is not moored or attached to the seafloor. And so as these colors increase from light to dark blue, this is showing how the buoy is progressing in time. So we started about a month ago in June 24th, and then now we are almost at July 24th. And so the buoy was deployed here. You can see it did this sort of big loop right here, and then sort of did some small spirals as it traveled westward to where it is now, or at least 11 hours ago. And what's pretty interesting is that you can see, right, so the buoy's motion is sort of the resultant of the ocean impacts, so the waves and the currents, as well as what the wind is doing. And these small spirals that you see here are actually called inertial oscillations. And these are actually the result of sort of the combination of the wind and the ocean currents and the fact that the Earth is moving or spinning around.
Wow, we thought it was a nod to One Ocean.
Yeah, the one. That's funny.
The
Yeah,
oh.
exactly. I like that interpretation a lot better. All right, and then so moving on to the dashboard. So this is accessible by everybody. Well, all these charts are. But so here we can see a significant wave height or the wave height over time. And so
Wow.
you can see that is, yeah, so there was sort of this big wave event right here, right, where the waves were as high as about 3 meters. So, you know, uh, what's that, about 9 feet,
Yeah,
right?
Yeah.
a little over 9 feet, almost
Over
10.
9 feet, right? Yep. So pretty big waves. At least relative to the surrounding conditions, right? So on average, it was about 1.5 meters. So we'll go back to that event later. But we can scroll down. We can also look at, again, this is the buoy's trajectory, but now the trajectory is colored by water temperature at the surface. And so it's about on average, say about 11, maybe 12 degrees, which is somewhere in the 50 Fahrenheit range. Um, relatively consistent, but definitely getting a little bit warmer as time has progressed. Oh,
That one, there's a yellow dot kind of
yep.
towards. What is that from? Is
That
that
is
like,
probably, well, it could be a number of things. It could have been when you collected it in the air. I don't know how warm it was that day, but it could be the air temperature, or it could just be a bad point, maybe from impact or something like that. Yeah, great question. Sometimes we see a lot of sort of spurious points like that, which usually happen in the tail end of our deployments.
Oh, okay.
Yeah, yep. Either from, it being in the air before we deployed it, or it being, sort of impacted as it was taken out or dropped into the water. This buoy, I don't think had a salinity measurement, so that's why these are all zero.
Oh, okay. I
Yeah,
understand.
yeah. But then let's see, wave height by position. That one's pretty fun because we can see, sort of
Oh,
as around the wave heights. So here, around right here is this big wave event that we saw, where we
wow.
saw about 3 meter wave heights. And then since then, it's had a little bit of bumps in wave height, but nothing quite as intense as that. But that's always a pretty fun map to look at.
Are we
Yeah.
able to do that as well? You just scrolled in on that a little closer. Is
Yeah.
that?
Yeah. So you
Oh,
have this little cursor right here, and if you
yeah.
just click and drag, you can zoom into an area.
Oh, that's so neat.
Yeah,
Like thinking.
totally. And it would be really awesome if we had land on this map too, but this buoy is actually far enough offshore that it's generally all in the ocean.
Why would that be awesome to see land as well?
Just for context, right? To
Ah,
see how you mentioned fetch earlier, right? To see how much depending on the wave direction, how much distance there is for the wind to produce waves over time. And especially coastal effects are always really interesting to see. And then let's see, this last one is a bit more in the weeds, but here we are looking at what we call the spectrogram. And so this is looking at how the waves vary at individual frequencies or wave periods over time. And so here on the x-axis, we have the wave frequency. And so on the right, we have higher frequencies or shorter wavelength waves. All the way to the right, let's see, we have over here, when we have frequencies as high as about 0.5, those are waves that are about as long as 6 meters. And then at the other end of that, when we have low frequencies, these are much longer waves that are anywhere from hundreds of meters to about a kilometer in wavelength. What we see in this map or this image right here, is you see these really, all these bright spots are showing really where the wave energy is focused. So, for example, if we zoom in on this July 1st or 2nd wave event, the wind generating the waves and growing them longer and longer. As you can see, they actually see that a few different times throughout the deployment. So here are these different bright spots, and you can always see the sort of characteristics increases in wavelength over time. And so that's always pretty cool to look at. And so I was really curious about a particular wave event that we saw right here around, let's see, it started to pick up on June 30th and peaked around early morning, at least UTC, on July 2nd. And so I tried to pull out some historical weather data. I couldn't find a whole lot. But there's a very busy weather map. I'm thinking maybe it could be related to this low right here, this storm right here. But to get some more context, I actually pulled up data from a nearby weather station, another buoy that's actually fixed in position. So this is part of the National Data Buoy Center. So I pulled up data from station 46066 from just south of Kodiak, Alaska. It is, let's see, oops, sorry, busy map. Got a lot of buoys out there. It should be in this vicinity. Let's see. We got a lot of buoys out here. There
yeah.
it is. All right. Yeah, so let's see. So this is just south of Kodiak, Alaska, buoy 46066. And so this buoy is interesting because it measures both meteorological data, so wind and wave directions, as well as wave data. So just like our buoy, which measures wave data. It's a much bigger buoy. You can see right here that is a 3 meter wide discus buoy. So here's an image of it here in the lower right, much bigger than MicroSWIFT that we deployed. This would take a big ship to go out and deploy and maintain. And so it's cool. It's got buoy cameras. You can go look at the actual footage. You see sea spray on the lens right here. And we can also see sort of a summary of its conditions, at least on this past day. So it is reporting wind information, so wind direction, wind speed, wind gusts, atmospheric pressure, which would tell us about any storms, air temperature, water temperature. If you keep scrolling down, we can see the wave data that we are, at least our group is particularly interested in. And so wave summary right here, you can see it's reporting similar measurements as our MicroSWIFT wave buoy, on the order of about 3 feet. But what I did is I went back and I actually collected data from this buoy and I plotted over the same time that we have data from our MicroSWIFTs, just because I wanted to see what the wind was doing. And so right around, let's see, here we're looking at wind speed on the top panel. So the event I'm talking about on July 1st is this big spike in wind speed right here. You can see the winds picked up from about 5 meters per second all the way up to about 12 and a half.
Hey,
Yep, we can look at the wind and wave directions. That's pretty interesting to see. So here on the second panel right here, I am showing the wind direction in black and the wave direction in blue. And this is direction in degrees. That's measured from north clockwise. And so right around that time, we see waves and winds coming from about 200 or so degrees, maybe 250. And so that's what, southwest-ish.
Okay.
Yep. And then also we have significant wave height measured by this buoy. Again, about 3 meters around that time, which is what we saw. And the question I had when I first saw that this big peak in wave height is I was wondering whether this was, big long ocean swell that had been generated by a storm somewhere else in the Pacific, or whether it was just winds picking up and producing a local wind sea, as we call it, which are just locally generated winds and waves. And so this buoy actually gives us two separate measures, both of the swell wave height, which is shown here in blue on this bottom panel, and also of the wind sea or locally generated waves in red. And what we actually see is that this buoy is predicting that the actually it was the wind sea that was picking up. So this really was just locally generated waves, at least according to this first cut estimate, and that generated these waves. And actually, this wind sea, after it picked up, then developed into swell, which was measured right here in blue. So that's quite interesting to see.
hmm.
So yeah, any questions about that? I was just kind of curious about that big event we saw and kind of wanted to dig into it.
Do
So,
you? Oh, sorry, go ahead.
so can you correlate this with any seismic events?
Yeah, I was going to ask that too.
Oh.
Is it an earthquake up there, huh?
Yeah, maybe. I don't know. That's a little bit out of my wheelhouse, seismic events, but it's a great question. Do you have any hypotheses?
Well, no, I was kind of curious about it because they had the big 7.3 or 4 earthquake, and it was very close to where we deployed the buoy. Wondered if it picked up anything, and then it had continual earthquakes around there. But I did wonder if it picked up anything.
Yeah, we should check the date on that. Those would definitely probably, right, be longer waves from seismic activity, which could potentially be outside the range that we measure with the buoys. The longest wavelengths we saw with the buoy are typically on the order of 600 meters, so definitely less than a kilometer. Um, but I will have to look into that.
So what is your organization doing with all this data, all these buoys that you're deploying? What data does this go to? How are you guys using it, and why is it important necessarily?
Definitely. There's a number of reasons. It really depends on the different project and where we're deploying them. So a lot of my work has been focused on hurricanes, which I realize is quite far from where we're looking at right now. But with the goal of improving coastal impacts, right? So waves are a big contributor of total water level during storms and also impact and damage, both ships offshore as well as infrastructure on land. We consider the same effects when we think about places like the Arctic. So there's a lot of soft permafrost in the soil there that waves really sort of beat up and melt and cause high rates of erosion. And so we're really interested in measuring the wave climate along the coast of the North Slope of Alaska to understand how it varies seasonally and also how ice impacts those trends. and how waves interact with ice. So typically we think of, when waves are generated in the open ocean, there might be a certain wave height offshore, but then as waves go into ice, the ice actually causes the wave heights to decrease as they go into the ice. So it actually acts as a sort of seasonal buffer along the coast. Yeah.
Yeah, that's fascinating, which is really neat because we hopefully can deploy something over on the other side where to be in your hurricane alley
Yeah,
there.
that would be awesome. Yeah, hopefully you were all safe from hurricanes, but we always
Yeah.
love to see the big waves that we measure with hurricanes.
Have you guys seen in the past like 10 years an increase in wave height with some of the multi-year ice melt happening?
Yeah, definitely right. So the ice is melting, and as a result, there is much more open water to generate waves along. And that's actually something my advisor, Jim Thompson, has studied quite a lot and published a big paper on it in 2014. So yeah, great question.
Do you communicate with many of the communities up north about just sharing this data so they can do work to prevent coastal erosion?
Yeah, definitely. Yeah. So our group has done a number of outreach events up on the North Slope and has coordinated with different scientists up there and community members. That's actually a big focus of this backyard buoys project. So you can see here on this map right here for the backyard buoys, there's a number of buoys that are located along the North Slope of Alaska that were sort of deployed. So here, for example, is Ukqiavik right here, and you see there's a number of buoys that have been deployed off the coast right here in collaboration with these community members to measure waves offshore of the coast.
Oh, that's so
Yeah.
Yeah, we might need to do that then. And it looks like those ones are the battery's all dead on those
You
ones.
are right. Yeah.
Do you know, so when you deploy these, do you
Yep.
know if the communities there are like constantly checking it? Like, do you have like a meeting with them and they're like, okay, or how does that work necessarily, the communication?
That's a good question. I haven't been directly involved. Jim would know better.
Be a
Um,
gym question.
Well, they did. It was interesting when we were in Nome.
yeah.
Um, there's a whole bunch of barges that are getting loaded with rock, and we were curious about what was going on.
Yep.
So it's going to, it's going to Barra. It's going to make
right.
breakwater. They're adding breakwater because the whole front it's like Shishmaref. It's just getting eroded into the sea.
Wow.
So I'm guessing that some of the buoy, I'm just guessing here that some of the buoy information was going to support, the big engineering project. It's huge.
Yeah.
And rather than move the town, they're going to try and put in a breakwater.
Yep. Yeah, coastal engineering.
Very cool.
Big challenge.
Very cool. And for your work for the hurricanes, how does that necessarily work? So do you kind of just watch when a storm comes in and then do you watch the wave height and then correlate it to the damage you see on shore? Or how does that's so interesting that you like study hurricanes and wave height and stuff.
Yeah. Yeah. Thanks, Grace. So that project's really fun because, yeah, like you mentioned, we are watching the forecast all summer long during hurricane season here in the Northern Hemisphere. And once we see a disturbance forming that we think might evolve into a tropical cyclone or a hurricane, we actually have project partners in the Naval Research Laboratory who we actually fly our buoys out to them. And then I also go out and travel with them. We load up this big airplane with instruments and we go fly down, usually to the Gulf of Mexico, depending on the hurricane, and then deploy them in arrays along the coast to measure wave action all along the coast. And then we work with teams that do storm surge modeling to then relate those wave heights to coastal damage and help improve those forecasts.
Oh, interesting. Wow.
Yeah.
So it's a preventative measure to help predict storms.
Definitely. I mean, so the data can, of course, be read, and ingested real time, like we're seeing here. But also, it's a bit of a longer game in the sense that we are seeing how those models performed and then trying to see if we can use that detailed wave data to improve them in the future.
That makes sense. Okay. Very cool. That must be pretty fun being able to fly out there and drop it.
Yeah, it is really fun.
Very
Yeah.
interesting.
If
And
you
then I
wanna-
had,
Yeah.
If you want to come with us to Cape Horn, we can go out from Cape Horn and drop a buoy. I don't know if you have any there, but I'm looking forward to doing that. So there you go.
That would be awesome. Yeah, I'll be in Woods Hole as of next month, so maybe feel free to swing by and pick me up.
Uh-huh. Thank you. Oh, fabulous.
It
Yeah.
would be good if we looked at what your map is of where they're dropped on the East Coast, so that we're adding to the data and not just camping on somebody else's territory.
Oh, sure. As far as collecting wave heights.
Yeah, yeah.
Yeah. Yeah. So like the big ones, right? So the National Data Buoy Center, which I mentioned earlier in one of these, yeah, right here. So there's, I'm sure you're already familiar with this, but it would be cool. I mean, sometimes we're interested, right, in deploying them right next to each other so we can see how they compare, but also we can use our buoys to fill in the gaps. So this group has a lot of buoys on the East Coast. Not all these are measuring waves, but quite a few of them are. And then this
Wouldn't that
also, yeah,
if we sailed offshore there and dropped one?
No
Yeah.
gravity.
We will be.
right here.
All right. Say hi.
Yeah, we'll stop at Woods Hole for sure.
Yeah.
Will you actually?
Yeah,
Yes, yeah.
but that will be because they're also working with us for the pole-to-pole kelp study. We're working with Tom Bell there, Dr. Tom Bell.
Very cool. That's awesome to hear. Well, maybe I'll get a chance to meet you then.
Yeah.
I would love to, if you can reach out to Jim. I think it sounds like we might need to drop a buoy up this region because it sounds like it might be very helpful.
Yeah.
And if he has a latitude, longitude, or an idea of where, and if we can, we will try to do our best to do it in that area. Of course, it's all ice dependent and weather dependent, but might be neat.
Do you find that many buoys you drop up in the Northwest Passage, do you find they get impacted, like injured or hurt by ice? Is it pretty easily breakable? Okay, yeah.
That is pretty common, especially the smaller buoys. It's very easy for them to sort of drift close to the ice and then get sort of crunched in the ice. And we very quickly see them stop reporting. That's the thing.
Yeah. Well, keep track of us, please.
Exactly.
I actually had a question for the backyard buoys program. You pulled up our buoy and you were able to show the wave direction. Is it possible to go back in time and see like from a month ago the wave direction, or is it just current live and it doesn't save past?
Right. I believe it's just current because that's something I was really trying to do myself. I wanted to pull up historical data and look at that big wave event. But I believe just on this application, you can only look at sort of the recent measurements.
Okay.
We can, let's see, the dashboard does allow us to go back in time, right? So this is basically the whole time record of the buoy. So this is probably a good tool for doing that.
Okay.
This is right about when you deployed it, and then up until it started to lose battery a few hours ago. Yeah. Yep.
And so our data, we'll be able to still continue to look at this data.
Yep.
It'll be here, correct?
Yep.
I have one more quick question. Is the the reason why it's not being collected is just because there's not a sensor on these buoys for that?
Yeah, I don't think there was a salinity sensor on this buoy. I think there was just a smaller temperature sensor.
And that's for all 8 of them.
With you?
Do we have a buoy with us?
Yeah, you can tell they'll have if there's like a big blue instrument on the bottom that's probably like a few inches long, that would be this salinity temperature depth sensor.
Okay.
So can the buoy right now, could we turn it on and off with that wand? Can we just like turn it on and then are we able to turn it off again? Or is it once it's on, it's active and has to be dropped?
Nope, yeah, you can turn it off. So right, so you swipe it on one side and then the other side, if you swipe it with the wand, it should turn it off.
Okay.
So
Okay, great.
yeah, so like for example, if you were in some big waves and you wanted to see if you could measure them from the boat, you could swipe it on for a day, attach it to the boat, and then collect it so you save some battery life. But just to see if it works, that could be cool. And they
Okay.
last, where you are probably, I mean, the one we deployed was about a month, right? So it's definitely have some time to work with.
But if we're turning it on and off, I mean, it's going to extend the battery life, I would think.
Exactly.
Yeah. And I'm assuming that you're not using lithium batteries because you ship these all over the place. Is that the deal?
Yeah, exactly.
Yeah.
Yeah. Some projects we do use lithium, if we're looking for like a a longer deployment where we know we're going to go back and collect them or we've taken them out. But for these sort of like more expendable deployments, we use Aqualine.
Listen, we really appreciate all your time. It's been so interesting and really fascinating. So thank you very much, Jacob. And we really do look forward to seeing you at Woods Hole on the other side.
Yeah, thank you so much. This has been great.
Flags are flying and the laughter soars, salt on their lips as adventure roars.